Okay, Assalamualaikum. My name is Muhammad Azim Afifi bin Yahya. My matric number is AE190141. I'm gonna present about introduction of our project. In this project, we use finite impulse response (FIR) and infinite impulse response which is IIR. Okay. Finite impulse response filter always permit linear phase, whereas the IIR filter are more challenging to regulate and do not have a fixed phase. The FIR filter is stable than IIR filter. IIR filter can contain restricted cycle where the FIR cannot. And FIR is like an analog history, but for the IIR is an analog derive. Okay, for the FIR filter rely on the linear phase feature, where the IIR filter is used in non-linear application. Although the FIR offer a significant better latency properties than IIR. Okay, IIR filter is rely on both input and output, while the FIR filter only depend on the input. Okay, for the FIR filter, used for the higher order tapping, while the IIR filter is better used and suit for the lower tapping. IIR filter might become the unstable while the tapping higher order. Okay, for the last introduction, we will analyze the IIR and FIR filter using the lecture supply and transfer them from the Microsoft Excel to the MATLAB software to be simulate and run it. Okay, that's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nishara binti Abu Bakar and my matric number is C102222. I will explain about the methodology of our project. In this project, we use MATLAB software to complete our task. To research and develop the systems and technologies that will transform the world, engineers and scientists have built the development framework known as MATLAB. MATLAB enables you to move your thoughts from study to implementation by deploying to enterprise applications and embedded system. So before we do the simulation, we have created a flowchart to make sure the procedure of making this task is going smooth. So this is our flowchart. Firstly, we open the MATLAB and then we give the command. After that, we need to put the value of amplitude. So here we have two processes, which is FIR filter and IIR filter. After we put the value of the amplitude, we need to check there is error or not. If there is any error, we need to repeat the process, which is we need to put the value of the amplitude but with the new one. If there is no error, we can proceed to the next process, which is plot the graph, and we can end the process after that. So that's all from me, and thank you.
Hi, my name is Ismail Gavin Ayohan XM. My matrix number is AE100121. So today I'm going to demo our group project for FIR. So this is this two line is for the clearing, and then this is for this fourth line is to read Excel that lecturer gave us, which is the signal, and X is for the TS in the TS, which is time second in the first row of the Excel, and then this is Y is equal to the amplitude in the Excel, and then S is length equal to totality, and then this y equal to fxy. Figure 1 is actually just the original signal that our lecturer provides us. So first is plot x and y, and then we put the title, which is signal group 3, and then we put grid, and then for the x level is time second, and then for the y level is volt and v. For the DFT, which is discrete Fourier transform technique. For the figure 2 is basically just the discrete Fourier technique. We just subplot it, and then we put the original signal at the top, and then we put the Mach spectrum, and then for the FIR is finite impulse response filter, and for the DT is the mean of different uh, x which to find the sampling rate, and then the fs is the frequency sampling, which is 1 over dt. T is equal to this, and then PLO FIR1, then this is for this. For the figure 1 is we frac for PLO, and 1 for outlaw is equal to the filter PLO 1 and y. For the figure 4 is we compare the original signal and the filter. So we use subplot, and then we plot t and y, then we use ys and y lim equal to y lim, and then subplot again and plot the t and the outlaw, and then put the title, the filter signal. So this is for the sound later. We will hear it. And for the convolution is we use con equal to the convolution y and BLO. For the figure 5 is basically just the convolution. I will run this coding. We wait for a few minutes, a few seconds. So that is the audio that we have filtered. This figure 1 just the signal that our lecturer gave us, and then this is DFT technique, and then for the figure 3 is this is the magnitude, and then this is the phase. You can see it's the graph. And then for figure number 4 we just compare the original and the filter. As you can see, these are the original signal, and then this is the filtered signal, and the fifth figure is the convolution signal. So I think that's all from me. Thank you. I'm gonna pass this to Ridwan Shakir for the IIR filter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rizwan Shakir bin Muhammad Amzani. My matrix number is CE190085. So I will present to you for my part about the project IIR. So this the first one, I will show you the code for project DSP IIR for section 3 group 3. So the first one we have CLC, which is clear. So we have Q equal to readable for Fs equal to 200, X equal to Q, and Y equal to Q. So X equal to FFT, Y, F equal to link space for length X. For figure 1, we have subplot for plot XY, for title signal group, X label for time, and Y label for volt. So the subplot for plot F2, apps, length X, grid, title, we have magnitude spectrum, and then we have a subplot, plot F angle X, grid for title phase spectrum. For the next one, we have IIR the continuing for project IR, FC equal to 94. We have FS equal to FS. We have APK equal to ELLIP. Then APK equal to ELLIP again. And then we have the num, and then we have HW equal to frequency, number, and then for the number, and then we have a bilinear for num, then FS and FSC. And then we have FV2 num, then and FS. For out signal, we have filter num, then and Y. For figure 2, we have subplot for plot X out signal for blue, X label time per second, X label equal is amplitude. For the title filtered signal for IIR filter. And then we have Y equal to FFT out signal, S link space, and then for the subplot plot S2 Y length Y blue grid title for magnitude spectrum after filtering. For subplot plot angle Y blue grid title for phase spectrum after filtering. So for the next one, we will run project IR to get the waveform. So we have to wait for a second for it pop up the result. So the first one, we have the figure 1. The first waveform for volt signal group 3, and then the second one we have a magnitude spectrum, then the third one we have a phase spectrum. So for the figure 2, we have the filter signal for IR filter. We have the amplitude, and then we have a magnitude spectrum after filtering, and then the last one we have a phase spectrum after filtering. And then the last but not least, we have the magnitude response dB. So these are how the graph looks like for magnitude response in dB. So I think that's all from me. Thank you. Assalamualaikum.
Assalamualaikum, my name is Muhammad Asim Afifi bin Yahya. I'm gonna continue the last part of our project, which is the conclusion. This project is compare IIR versus FIR in the term of magnitude response, magnitude spectrum, and the other factor to obtain close optimal filter response. We use a convolution phase spectrum and the minimal filtering order. FIR and IR are the two principal categories of a digital filter used for signal filtration. The main difference between FIR and IIR filter is the former offers a finite range of impulse reaction time. IIR is a kind of filter that generates an infinite duration dynamic system impulse response. Cross correlation is utilized by matching filter. This may be seen as access to the input signal against a predetermined pulse shape. A cross correlation of the input signal and a time shift replication of impulse response make the IIR convolution. IIR filter have a stronger magnitude response, even though the FIR filter have a better and more clear delay response. Here is a critical that filter phase is linear to reduce distortion of the signal output. Okay, that's all from me, and that's all from our group. Thank you.